On the afternoon of January 22, 1945, at precisely 14:30 hours, Captain Donald Warner stood in a tank depot at Maastricht, Netherlands, examining what would become one of the most unusual armored vehicle modifications of World War II. Before him sat an M4A3 Sherman medium tank with severe frontal damage from an 88mm anti-tank round, and approximately 50 yards away, lying inverted in a salvage yard, was the forward fuselage section of a P-51 Mustang fighter that had crashed during a forced landing 3 days earlier. The pilot had survived, but the aircraft's fuselage was broken just aft of the cockpit, rendering it unrepairable as an aircraft. The Sherman tank, serial number USA 30456712, had been knocked out during fighting near Aachen on January 18, 1945. An 88mm round had struck the glacis plate at an oblique angle, penetrating the frontal armor and entering the crew compartment. The driver and assistant driver were killed instantly. The commander, gunner, and loader survived by evacuating through the turret. The tank's engine, transmission, suspension, and turret were undamaged. Only the forward hull section required replacement or extensive repair. By January 1945, Allied armored forces in Northwest Europe faced an increasingly difficult tactical situation. German forces were deploying armored vehicles with substantially more powerful guns than American tanks possessed. The Sherman's standard 75mm M3 gun could not penetrate the frontal armor of Panther or Tiger tanks at any practical range. Even the improved 76mm M1A1 gun, mounted on later Sherman variants, struggled against German heavy armor. The Sherman's armor protection was similarly inadequate. The glacis plate was 51mm at 56 degrees, providing effective thickness of approximately 91mm. This was sufficient against German 50mm and short-barrel 75mm guns, but inadequate against the 75mm KWK-42 on Panthers, penetration of 138mm at 500 meters, and utterly insufficient against the 88mm KWK-36 on Tigers, penetration of 165mm at 500 meters. Sherman crews faced opponents they could neither penetrate nor resist. However, the Sherman possessed one significant advantage: reliability and availability. American factories produced approximately 2,000 Sherman tanks in late 1944 and early 1945. Spare parts were abundant. Replacement vehicles arrived constantly. The Sherman was mechanically reliable and easy to maintain. The fundamental problem was not the chassis or automotive components, it was the armor protection and armament. The P-51 Mustang represented a completely different engineering approach to survivability. Fighter aircraft could not carry heavy armor. The weight penalty would be unacceptable. Instead, the P-51 relied on speed, maneuverability, and minimal exposure time to enemy fire. The aircraft's structure was lightweight aluminum alloy, optimized for strength-to-weight ratio rather than ballistic protection. However, the P-51's forward fuselage section contained several features that Captain Warner found extremely interesting from a tank design perspective. The nose section housed 6 Browning AN/M2 50 caliber machine guns with 1,880 rounds of ammunition. The cockpit provided excellent visibility with a bubble canopy offering 360-degree vision. The entire forward fuselage was aerodynamically streamlined, presenting minimal frontal area to oncoming fire. The crashed Mustang's forward fuselage was intact from the propeller spinner to just aft of the cockpit, approximately 16 feet of structure. The 650 caliber guns were undamaged. The bubble canopy was cracked but repairable. The ammunition bays were empty but structurally sound. The section weighed approximately 1,200 pounds, including the guns, cockpit controls, and structural components. Warner examined the crashed P-51 throughout the afternoon of January 22nd. He was not thinking about repairing the aircraft. The aft fuselage was destroyed, and the Merlin engine had separated on impact. He was thinking about the visibility that bubble canopy could provide to a tank commander, and the concentrated firepower those 6.5 caliber guns could deliver against German infantry and light vehicles. Sherman tanks suffered from severely limited crew visibility. The driver and assistant driver had narrow vision slots in the hull front. The commander had a cupola with narrow vision blocks. The gunner looked through a telescopic sight with minimal peripheral vision. Tank crews were frequently blind to threats approaching from flanks or rear until those threats were already engaging. The P-51's bubble canopy offered visibility that no tank commander's cupola could match. Sitting in that canopy, elevated above the hull, a tank commander could see in all directions without the restricted view imposed by armor plating. This visibility advantage could mean the difference between detecting threats early and being ambushed. At 1600 hours, Warner called a meeting with Major Robert Hendricks, the depot's senior maintenance officer, and Master Sergeant Carl Jensen, the chief of the tank repair section. The proposal was radical and unprecedented. Remove the damaged forward hull section from the knocked-out Sherman, fabricate a mounting adapter, and install the P-51's forward fuselage as a replacement for the tank's bow. The engineering challenges were extraordinary and unlike anything previously attempted. The P-51 fuselage section weighed approximately 1,200 pounds, roughly half the weight of the original Sherman bow section. This weight reduction would shift the tank's center of gravity rearward, potentially affecting handling and flotation characteristics. However, the reduced weight would also improve power-to-weight ratio and potentially increase maximum speed. The dimensional compatibility was surprisingly good. The P-51 fuselage width was approximately 4 feet at the widest point, narrower than the Sherman's hull width of 8 feet 7 inches. The fuselage height from the bottom of the wing root to the top of the canopy was approximately 5 feet, close to the Sherman's original bow height. The fuselage length of 16 feet would extend well forward of the Sherman's original bow, but this was acceptable and might even provide additional obstacle crossing capability. Master Sergeant Jensen proposed fabricating a steel transition structure that would mate the P-51's circular fuselage cross-section to the Sherman's rectangular hull opening. This adapter would be welded to the hull and would incorporate mounting points matching the P-51's original attachment fittings. The adapter would need to support not only the static weight of the fuselage, but also the dynamic loads from vehicle movement over rough terrain. The crew positions would require complete reconfiguration. The original Sherman design placed the driver and assistant driver in the bow, the commander and gunner in the turret, and the loader in the turret basket. The P-51 installation would eliminate the bow driver position. The fuselage cockpit could only accommodate the commander. The driver would need to relocate to a different position, possibly in the turret or in a modified position within the hull. The weapons integration was simpler than expected. The 650 caliber guns in the P-51 nose were already equipped with electric firing solenoids. These could be wired to a firing control in the commander's position in the P-51 cockpit. The gun's convergence was set for 300 yards, appropriate for air-to-air combat and also useful for engaging ground targets at typical tank engagement ranges. Ammunition supply would require modification. The P-51 carried 1,880 rounds in ammunition boxes within the wing roots and forward fuselage. These boxes could remain in place, but the ammunition would need to be loaded through access panels rather than through the wing structure as in the aircraft. Reloading would be time-consuming, but feasible. Captain Warner faced a command decision. The modification would consume substantial depot resources, at least 3 weeks of work by skilled mechanics and welders. If the modification failed, a potentially repairable Sherman hull would be destroyed. However, if the modification succeeded, it could create a tank with visibility and anti-infantry firepower unprecedented in armored warfare. On January 23rd at 800 hours, Warner authorized the modification. By 10 o'clock hours, the damaged Sherman was positioned in the main repair bay. The salvaged P-51 fuselage section was transported from the salvage yard and positioned adjacent to the tank. A team of 8 mechanics and welders began the work under Jensen's supervision. The first phase involved removing the damaged bow section from the Sherman. Using cutting torches, the team cut along the hull just forward of the turret ring, removing the entire glacis plate, bow section, transmission housing cover, and forward hull structure. The work took 2 days and left a large rectangular opening in the front of the hull, exposing the transmission and final drives. The Sherman's transmission was undamaged despite the 88mm penetration. The final drives, suspension components, and steering controls were intact. The hull structure at the cut line was solid and provided good attachment points for the adapter structure. The tank was mechanically sound from the turret ring rearward. The adapter structure fabrication began on January 26th, and Jensen designed a framework consisting of heavy steel channels forming a rectangular opening matching the hull cut line, transitioning to a circular opening matching the P-51 fuselage diameter. The structure was built from quarter-inch steel plate and heavy-duty steel channel sections salvaged from damaged vehicles. The fabrication took 4 days of intensive metalworking. The adapter weighed approximately 340 pounds when completed. The structure was 3 feet long, transitioning from the rectangular hull opening, 8 feet 7 inches wide by 4 feet 6 inches high, to a circular opening 4 feet in diameter. The circular opening incorporated bolt holes matching the P-51 fuselage mounting points. Installation of the adapter structure occurred on January 30th. The framework was positioned in the hull opening and welded to the hull structure at 16 points around the perimeter. The welding took 14 hours, with Jensen personally inspecting every weld for structural integrity. The completed installation created a rigid transition from the Sherman hull to the P-51 mounting interface. The P-51 fuselage section required extensive preparation before installation. The 6 50 caliber guns were removed, inspected, cleaned, and reinstalled. The ammunition boxes were cleaned and prepared for ground vehicle use. The cockpit controls were stripped of all flight-related equipment. Throttle, mixture controls, propeller controls, and flight instruments were removed. A simple seat and basic vision equipment remained. The bubble canopy required replacement. The original canopy had been cracked during the crash. A replacement canopy was obtained from another crashed P-51 in the salvage yard. The new canopy was installed and verified to operate smoothly on its sliding rails. Installation of the P-51 fuselage on the Sherman hull occurred on February 2nd at 900 hours. A mobile crane lifted the 1,200-pound fuselage section and positioned it over the adapter structure. Alignment proved challenging. The fuselage needed to be oriented precisely to ensure the guns pointed straight forward and the cockpit was level when the tank was on flat ground. The alignment process required 6 hours of incremental adjustments. Jensen used surveying equipment to verify that the fuselage longitudinal axis was parallel to the tank's centerline and that the gun's bore axis was level and centered. The fuselage was secured to the adapter structure using 24 high-strength bolts through the original aircraft mounting points. The gun firing system required rewiring for tank use. The original aircraft system used 28-volt electrical power. The Sherman used a 24-volt electrical system. An electrical adapter was fabricated to ensure proper voltage for the gun solenoids. The firing control was installed in the P-51 cockpit, consisting of a trigger mounted on a control stick fabricated from steel pipe. The driver relocation proved to be the most challenging crew accommodation issue. The original Sherman driver's position in the bow was eliminated by the P-51 installation. Jensen designed a new driver's position in the right side of the turret where the loader normally stood. The driver would operate the steering controls and transmission using extended linkages running forward to the transmission. Vision would be provided through a periscope mounted in the turret roof. The loader was relocated to the left side of the turret, exchanging positions with the driver. This was awkward but workable. The 75mm gun could still be loaded from the left side, though the loader had less space than in the original configuration. The combat effectiveness would be somewhat reduced, but the vehicle remained functional. The modified tank's appearance was extraordinary and unlike any armored vehicle in existence. The Sherman's hull and turret were recognizable, but instead of the characteristic sleek lacis plate, the tank featured a sleek aircraft fuselage extending forward from the turret ring. The P-51's distinctive nose shape with 6 gun barrels topped by the transparent bubble canopy created a surreal combination of aircraft and tank aesthetics. Ground testing began on February 5th. The modified tank was started and driven around the depot yard at low speed. The handling was unusual but acceptable. The reduced bow weight made the steering lighter than a standard Sherman. The forward weight distribution caused the suspension to ride slightly higher in front, creating a nose-up attitude of approximately 2 degrees. Visibility testing from the P-51 cockpit revealed extraordinary results. Captain Warner positioned himself in the cockpit canopy and had the tank driven around the depot while he evaluated sightlines. The visibility was far superior to any tank commander's cupola. Warner could see 360 degrees with minimal blind spots. He could see the ground immediately in front of the tank, something impossible from a normal Sherman commander's position. The weapon system testing occurred on February 7th at a designated range outside Maastricht. Targets were set up at 200, 300, and 400 yards, typical engagement ranges for anti-infantry weapons. Warner positioned himself in the P-51 cockpit and aimed the guns using a simple ring sight mounted on the instrument panel. The first firing test occurred at 1,000 hours. Warner aimed at the 300-yard target and depressed the trigger. All 6 guns fired simultaneously with perfect synchronization. The noise inside the tank was substantial, louder than the 75mm main gun firing. The sound was described as a continuous roar rather than distinct gunshots. The muzzle flash from 6 guns was spectacular even in daylight. The target, a simulated building facade constructed from wood and sandbags, sustained catastrophic damage. Approximately 240 rounds struck the target in 3 seconds, a concentration of fire that shredded the structure completely. The effectiveness was far beyond anything achievable with the single .50 caliber machine gun typically mounted on Sherman tanks. However, the firings revealed a significant problem. The gun muzzle blast and smoke obscured the commander's vision completely during firing. The P-51 cockpit position, directly behind the guns, placed Warner in the worst possible location for muzzle blast exposure. After firing, it took several seconds for the smoke to clear enough for Warner to see targets again. Warner conducted additional firing tests at all 3 ranges. Accuracy was excellent. The guns were precisely aligned, and the convergence pattern created a tight impact area at typical engagement ranges. The ammunition capacity of 1,880 rounds provided approximately 23 seconds of continuous fire, or more practically, 40 to 50 3-second bursts. This was substantially better than the 300 to 600 rounds typically carried for hull-mounted .30 caliber guns on standard Shermans. The tactical evaluation occurred on February 10th during a simulated combat exercise. The modified Sherman operated with a platoon of standard M4A3 tanks in a mock attack against fortified positions. The exercise revealed both the advantages and limitations of the modification. The visibility advantage was immediately apparent. Warner, positioned in the elevated P-51 cockpit, could see threats and targets that other tank commanders could not detect. He spotted simulated anti-tank gun positions, enemy infantry in concealment, and obstacles that would have been invisible from a normal tank commander's cupola. The 360-degree vision allowed him to maintain situational awareness far better than conventional tanks. The 650 caliber guns proved devastatingly effective against infantry and light fortifications. When engaging simulated machine gun nests and infantry positions, the concentrated firepower suppressed targets completely within seconds. The psychological effect was substantial. Opposing forces reported that the volume of fire was overwhelming and unlike anything experienced from conventional tanks. However, the modification also revealed serious limitations. The P-51 fuselage provided zero armor protection for the commander. Warner was completely exposed to any incoming fire that could penetrate the thin aluminum skin, essentially everything larger than rifle rounds. A single machine gun hit to the cockpit could kill the commander. The vulnerability was extreme and unacceptable for sustained combat. The forward extension of the fuselage affected the tank's maneuverability negatively. The P-51 nose extended approximately 6 feet beyond the original Sherman bow. This increased the tank's turning radius and made navigation through tight spaces difficult. The nose struck obstacles that a standard Sherman would have cleared. The long nose was a liability in urban combat or heavily forested terrain. The driver's relocated position in the turret created crew coordination problems. The driver could not see the ground directly ahead. He relied on instructions from the commander. This slowed movement and made precise maneuvering difficult. The driver's position also interfered with turret rotation. The turret could not traverse freely because the driver occupied space normally used for turret basket rotation. Captain Warner prepared a detailed evaluation report on February 12th. The report concluded that while the modification demonstrated innovative thinking and provided remarkable visibility and anti-infantry firepower, it was fundamentally unsuitable for combat operations.